Welcome back to Computer Science and Engineering 120, Learning to Code. This is Module 12, Organizing Data, Part 1, Searching and Sorting. Given a collection of elements, in particular an array of elements, we may want to search it for a particular value or element. There are several variations on this problem, for example, finding the minimum or the maximum element in an array of numbers. We may not always be searching for a number, however, so the test for equality can be complex, requiring the use of a callback. We'll take a look at two basic searching algorithms, linear search and binary search. Linear search is pretty straightforward. Given an array, you simply want to iterate through it one by one and test equality on each element. If you find the element that you're looking for, you stop and return either the index at which you found it or the element itself. Or if you get through the entire array and do not find it, then you can return some sort of a flag to indicate that you did not find it. Let's take a look at a demonstration. Here we have an array of 20 elements. We're going to search for the element 8. It checks the first element. 2. It's not equal, so it moves on to the second element, 10. Likewise, 20, 6, 3. None of these elements are equal to 8, so it continues on until it reaches the element that you're looking for, at which point it stops and says that it found it. In the demonstration, we only had to look through about a third of the array before we found it. In the best case, we could get really lucky and find it at the first element. In the first case, we may end up finding it at the last index, or we may not find it at all. On average, we would perform about n divided by 2 comparisons or operations on an array of size n. The amount of work is linear with respect to the size of the array, thus the name of the algorithm, linear search. Binary search is a little bit different. It makes an assumption about the array, in particular that the array is sorted. Suppose that we want to search for the element k, or the key k. First, we start by examining the middle element, m. If m is equal to k, then we found the element that we're looking for and we stop. Otherwise, if m is less than k, then if k exists in the array, it must lie in the upper half of the array. If k is less than m, then k must lie in the lower half of the array. Let's take a look at an example. Here the elements are sorted, 1 to 20. If we want to search for 8, we start by examining the middle element, 10. 8 is less than 10, so it must, if 8 exists, it must lie in the lower half of the array. Essentially, we've cut out about half of the elements in the array under consideration. We repeat this process by looking at the new array from index 0 up to 8, and look at the middle element now, 5. 8 is greater than 5, so again we can cut the array in half. We examine 7 and determine that 8 is greater than 7, so again we've cut it in half. At which point, looking at the middle element, we find the element that we're looking for. Because we cut the array in half each time, it's a much quicker algorithm than linear search. In fact, in general, it only requires about a logarithmic number of comparisons or operations to find the element that you're looking for. However, the input array does need to be sorted. As an example, consider an array with 1 billion elements in it. A linear search would require on average about 500 million operations. However, binary search would only require about 30 operations. This is a huge speed up and improvement over linear search. Consider another perspective. Suppose that we start with an array of size n and then double its size to 2n. Linear search would require twice as many operations because the number of operations grows linearly with respect to the input size. However, binary search, because of the nature of logarithms, would only require one more comparison. Clearly, binary search is much faster in general, although again it does require the array to be sorted. In JavaScript, there are several built-in functions that allow you to search. As of ECMA script version 5, you have access to the index of function. Unfortunately, it only works for numbers and strings, so it is somewhat limited. In ECMA script version 6 and above, we have the find function, which allows you to do an arbitrary search using a callback. Unfortunately, there are no binary search implementations in any version of JavaScript. No version supports it, but it can be added with a shim. Recall that a shim is similar to a polyfill, but whereas a polyfill is meant to be adding functionality that is expected to be there, a shim adds functionality that's not necessarily expected to be there, but that's nice to have.